What's up, everyone? This is Ryan here, and you are watching episode 22 of my Android developer live stream Q&A. So as you can see, I'm on vacation. I've had a whole 10-day vacation, so I haven't bothered to shave or anything, so I look like a homeless man, but that's totally fine. So basically, not a whole lot going on for me. As I say, I kind of just took a vacation. The ebook is basically done. I'm still just waiting on a bit of feedback from the proofreaders, and I'm also going to be setting up direct digital download from my website as opposed to only doing Amazon. So that's why it's been taking a little bit longer to kind of crank it out. But the book itself is basically done, and so it's just all the random little stuff that goes into releasing a product that needs to get done, and it is being done. But other than that, I don't really have any announcements. As always, I'd just like to start by thanking the following people for supporting me on Patreon. So that's Seth Keegan, Shan, Tina Fredericks, Tony Jones Jr., Trevor Halvorsen, Bassam Halal, Nanotech, Shadow, Mr. Bidwell, Sushil Chanda, and Elad Stavi. So to those people, I say thank you very much. And yeah, that's our commercial for today. Soon I'll be talking up my ebook as my daily commercial. So I'm excited when I can get to like sell my own shit to you. But anyways, what I wanted to talk about today, I didn't actually. Pretty much what happened last night is. I was hanging out with friends, and I just entirely forgot that I had to do the stream this morning, and I didn't really have anything planned until about 12 o'clock last night. But then I did get a comment from someone basically asking about ModelView Presenter last night, and then also I got a question this morning a little bit about ModelView Presenter. So I thought what I would do is I'll give kind of an overview and introduction video to ModelView Presenter, at least how I implement and understand it. And that'll be kind of what I open with for today's episode, and then we'll just get back into Q&A. So I have a tendency to ramble quite a bit, as a lot of people have noticed. So let's just get right into the lesson here. I see we've got a couple people. What's up? We've got, I'm not sure how to pronounce your name, Jaja, something like that. And then Monique. I'm not entirely sure what you're asking, Monique. Set the count badge. Unfortunately, it's been quite a while since I've worked with Firebase, and I don't think I've worked with that particular API that you're talking about, so I don't think I can help you there. Anyways, on to ModelView Presenter. So let's get started on that. The first thing I wanted to talk about is, so before we even get to ModelView Presenter itself, which I'll talk about what that is, I want to talk about why we even bother dividing things into 3-layer architectures, why they're usually 3 layers, and what does all this crap mean? What does ModelView Presenter mean? What does ModelView Viewmodel mean? All that crap. And basically, here's how I would summarize it, and I'll make use of my notes here so you're not just watching me jabber. So here's how I like to sort of introduce the idea. So most applications, we'll see how good I am at typing today. Most applications will require classes, or I'd even in brackets say code, just code in general, classes which do one of 3 things. So the first thing is, of course, drawing things on the screen. Now, for my first explanation here, I'm going to use very simple language, and then we'll get into more specific language as I get closer and closer to ModelView Presenter itself and how it works. But anyways, excuse me. So the first thing is we're going to need code to draw things on the screen / listen for user input. We're going to need code to sort of make logical decisions, and I'm kind of cheating a little bit, but in a way this will also be responsible for communicating between layers. And then you also will need code which manages storage and access to data. So that's kind of the first thing. Let me see if I have, do I have the Recyclerview app open? Yes, I totally do. So I'm not just trying to just get extra views on this. So what I would suggest is if you're totally new to software architecture and you're not quite sure like what is Model View Presenter, what's a 3-layer architecture, what I would suggest to you is check out my Recyclerview 2017 tutorial, because I've had a number of people kind of ask about Model View Presenter quite specifically. And the thing about that previous app that I built, the Recyclerview 2017 app, I called, let me just show you the code really quickly. Here we are. Why is that code not showing up? There we go. So I called the 3 different layers in this application as data, logic, and view. And I specifically didn't even say that this was Model View Controller or Model View Presenter or anything, but I would suggest you check out that, because basically what I'm doing there is you can pretty much think of it as Model View Presenter, or you can think of it as just a small part of a Model View Controller. The point I'm trying to get at is, like, don't overthink this stuff. At the end of the day, whether you're looking at Model View Presenter, Model View Controller, or Model View Viewmodel, whatever, whichever of those 3-layer architectures, at the end of the day, there's 3 layers for the most part, and you can give them different names and they can talk to each other in different ways and have slightly different responsibilities. But at the end of the day, data, you got a layer for data, you've got a layer for logic, and because the logic layer sits between them, it also talks to the other layers. So it's kind of logic and communication. And then you've got the view, which draws things on screen and listens for user input. So that's true. I can basically say that those statements are true of all of those architectures. So I just wanted to sort of overview, like, why are these things 3 layers generally? I hear my old friend the garbage truck, so there's going to be a bit of background noise. But so that's just to overview, like, why things are 3-layer architectures and what Model View Presenter kind of means. So you've got a layer that draws stuff on the screen, you've got a layer that handles logic, and you've got a layer that handles data. So that's like the highest level overview, of Model View Presenter there. So what I'm going to do next is we're going to get a little bit more specific to Model View Presenter. Now there's, as with all of these things, there's slight variations to how you can actually do it. And there's a specific variation which I try to apply, although I don't think I always manage to apply it 100% properly. But there's this fellow who's really, really good at software architecture, and his name is Martin Fowler. And he kind of divided Model View Presenter, which is just a way of dividing the responsibilities of different classes. We'll look at some code in a bit. He divided Model View Presenter into 2 different sort of variations. So number 1 was passive view, and number 2 was supervising controller. I'll be honest, I've actually forgotten exactly how supervising controller is different, but I generally look at passive view, and so we're going to kind of look at the sort of a passive view interpretation of Model View Presenter. These are all a bunch of big words. I don't want you to worry about that. Well, like, the words are not especially important. So let's look at an example of Model View Presenter. And what I'm going to focus on is like what it is and how to actually go about doing it, and how we actually decide whether something was Model View Presenter or not. Now, in most cases, like the code I showed you earlier, a bit of it, that's my code. The code that I'll be showing you for a moment is actually from one of the Google samples repositories. It's from the Android Architecture Blueprints repository, specifically on GitHub. So I would strongly suggest you check that out. That is Android Architecture Blueprints. This was the first time I saw MVP kind of done properly, and it was these open source repositories were a huge inspiration for me. So I don't normally like looking at other people's code and talking about it, but since it's basically Google samples, I'm just gonna use it because the thing is, if I were to show you how I currently do Model View Presenter in my code, I actually only use Model View Presenter for the front end. So, but anyways, we're not going to go into that today. Let's just keep things basic here, Ryan. So, the project I'll be looking at here, like I say, it's from the Google repository, the Google sample GitHub repository. I don't have a link to it, but you can just Google it. And basically how it works is a whole bunch of really good developers got together and built a note-taking app, except they built it a couple different ways. But most of them are to the Model View Presenter sort of style architecture. So how does Model View Presenter work? Or what does it look like specifically? So just to reiterate things, for each sort of feature, so when I say feature, I mean like, let's say you're in the Gmail app and you open up your whatever list of emails, that's one feature. And then maybe you hit the pencil button to write an email, that's another feature. So that's kind of what I mean by a feature of an application. It's like a sort of a use case or something. And you should be dividing those up in your application. You shouldn't be doing 5 things in like one activity, one feature. Anyways, when we look at this project, I know you can't see that super well, but we have add or edit task. We've got tasks, which just displays a list of tasks, and then we've got a task detail, which shows a detailed view of a task. So it's basically like a task app or a note-taking app is what they're building here. And for each feature, and so this is how Model View Presenter kind of works, is for each feature of your application, you're going to build a view for that feature, a presenter for that feature, and your model might actually be shared across multiple features. So you'll generally put that in a separate package, but just keeping in mind what I just said, I can open up any of the features and I will see a couple different classes. I will see, of course, the activity for each feature, and then I'll see a fragment, which you can think of as the view. Fragments are great views, so that's kind of my first little hint. If you're doing Model View Presenter, you don't have to use fragments as views, but I like to use them because to me they are purpose-built for that. They do have other responsibilities sometimes, but fragments make great views. We have a presenter, which the presenters themselves, let's open up task detail presenter, keep it all in the same feature. The presenters themselves are generally fairly plain, like they shouldn't have a lot of APIs and stuff in them. You can of course use something for concurrency, which we'll talk about later. That's a little more advanced. But generally speaking, they'll just be full of, they'll just talk to sort of a model layer and the view layer. So what I want to sort of point out here is we can think of this presenter. So we've got our view, and then we've got our presenter, and then we're talking to this repository, which you can think of as I would consider this the model in this case. Model is a slightly confusing word because sometimes it means just like a single, you could call just this task, plain old Java object, as a model. And then you could also call the databases, you could think of that as a model. And the reason why that's okay is at the end of the day, they're both responsible for storing data, and therefore they can be considered to be in the same layer. Anyways, just a random little tangent for people who are confused by the usage of the word model. So essentially what we've got going on here, oh yeah, my phone's ringing, shut the hell up. Essentially what we've got going on here is we've got our view, which talks to this presenter, and then the presenter talks to the repository or the model, and then it'll fetch some data from there, and then it will tell the view to display the data. So I've got a little bit of a graphic to hopefully make that a little easier to wrap your head around. And that graphic looks like this. So again, I've gone ahead and instead of thinking like presenter model, in this case, I just want you to replace logic with presenter and model or data with model. That's all that's going on here. Again, I like to call them different things when I'm just referring to 3-layer architectures in general. But essentially how this works is, for example, let's say the user clicks a button to create a new task. So that event is going to start in the view. So if I go back to the code for a moment, in the view, where is it? The view is, of course, going to have an on-click listener. So it's going to be listening for someone to click the floating action button here. Hopefully, you should be able to see that. When that happens, as you can see here, we've got these annoying lambdas. But when it gets clicked, it's going to say to the presenter, hey, this button was clicked. So essentially, so the event starts in the view. It's going to pass... oh, God, my voice cracked. What do I do? It's going to pass that message to the logic layer or the presenter, and the presenter is going to do what it needs to do. In most cases, the presenter is going to talk to the model or the data layer, and it's going to ask it for something. It's going to say like, hey, get me this data. Now, the thing is, what tends to happen is when you start to build more advanced architectures, more advanced programs, you can't always rely on single responses. So what I mean by that is, let's say we ask the database for a task. If the database is empty, it might return nothing. If the database has something, it'll return data. It might be empty. It might return an error. So essentially what's going to happen is the logic is going to say, hey, database or data layer, hey, model, get me the thing I need. And then the model or data layer is going to say, one of 3 things, and then the logic or the presenter is going to decide what to do. So in that case, if I go back to the code, which one here, and then to the presenter, there's different things that can happen. Again, we've got lambdas in here, so it makes it hard to read, but what happens is, this is essentially what happens. We've got on next, which is it's going to receive, in this case, just a single task. So in this case, that would be like this response here, return data. Or it'll say on completed, it hasn't found anything yet, or there is no data, which is this sort of middle path here. Or it'll say on error. It'll throw an error. And I just, as a random side note about RxJava, you do want to treat an error as something different than an empty database, because an error is like a critical failure, whereas an empty database is quite normal when you first start the application. Anyways, so I'm rambling a lot here, but hopefully I'm kind of explaining how this thing kind of works and sort of jumping between the higher level perspective and how you actually do it in code. So that's kind of how things work for the most part. So I just want you to think, we've got the view, which does 2 things. It draws the user interface, and it accepts on click. It listens for click events and things like that. And then it just passes that to the logic and says, hey, this thing happened. It doesn't make any decisions. The logic makes all the decisions. It tells the view what to do. The presenter, sorry, I'm confusing myself now. The presenter tells it what to do, and then it kind of just asks the model for data when it needs it. So there's really nothing especially interesting going on there. There's 2 more things I'd like to say. Why do we actually think of these things in layers, and how can you actually tell? Let's say, for example, I was looking at this code from my recycler. Actually, let's again look at the blueprints thing. So let's say just for some stupid reason, someone didn't name these things presenter, fragment, and model. How would I kind of know, or how would I figure out which is which? Like, how could I look at a project without seeing these names and just be able to tell which one is a model and which one is a view and which is a presenter? The simple answer is that I would look at its implementation. I would look at the actual code within the class. And now this is going to assume that whoever has written the class has applied proper separations separation of concerns, and they're following the single responsibility principle. But when I look at the presenter, I see basically that it's telling a view what to do, and it's asking a repository, a data storage mechanism, for stuff. So that's very plainly a presenter, or like a logic layer. And I think you already understand where I'm going with this, but basically the way that you kind of tell if someone has done model view presenter properly is the degree to which the code within the things that we call like view or fragment or presenter slash logic or model slash data, the code within it is cohesive to what the thing should actually be doing. And the more, there's a technical word that gets thrown around, which is cohesion. But basically, the better the thing actually does what it says it does, sort of the better you can tell whether something has a good architecture. So the last thing I'll talk about is the actual benefits of doing this, and then I'll shut up because I think I've been talking for over 20 minutes. But hey, what else is new? So the last thing is like the benefits of Model View Presenter, and let's just wrap this up quickly. So I've kind of gone over, hopefully in a way, like how to get started, or I've hopefully overviewed Model View Presenter for you. Let's just talk about the benefits. So these are the things that I personally observed when I went from kind of a really crappy Model View controller, half-assed architecture to Model View Presenter. Is so for starters, let me pull up. Would help if I had my notes open. There we go. So the first thing is system. So let's say I just want you to imagine if you're in a position where you don't really have any kind of solid architecture and you're thinking of switching to Model View Presenter, what do you get out of that? What do you get out of this? And I'll start by saying that at the end of the day, you need to just build an app using Model View Presenter. You need to just do it to actually see the benefits for yourself. But let me give you a brief overview. So number one, components / apps are easier to build. So why is that the case? Just really quickly, I want you to think of, like, let's say you're building a single class with 5 responsibilities. Necessarily that class is going to be enormous and complicated. And so when you divide your single class that does drawing things on screen and making decisions and storing data, when you pull that out into its own architecture, you've got 3 pieces which do more specific things. So when you're writing each part, it's less complex. Like, I don't really need to use big words here, I don't think. It's really as simple as that. When you pull your architecture into different parts, similar to if you were designing a house and you had let's say you're designing a house, should your bathroom also have a grill in it or an oven? Should your bedroom have a fridge in it? Maybe you'll find the odd architecture where that makes sense, but I guarantee it's either made by a crazy person or it's like a tiny apartment. Anyways, rambling. Yep, so components and apps are easier to build just because you're pulling things out and making them less complex in isolation. What were my other notes here? So components, yeah, easier to build. Easier to read. So this was one of the things that immediately drew me to Model View Presenter, is that when I open up again, I know you can't read these very well, but we've got, like, for example, a package called tasks, which displays a list of tasks. We've got a package called task detail, which shows a detailed view of tasks. And then within that, we've got a class that says task detail fragment. So I know for this particular feature, that's where most of the UI stuff will be. And that makes it easier for me to read. I think you get the point there. A couple more, just 2 more things. So it's easier to maintain. So again, like when you're looking at an architecture, which has good names and it's just pulled apart, modular, you don't need to think as much. You don't need to go, oh, what the hell did I write in here? Like this one class does 7 things. Where's the code to highlight some text bar or some text or something. Like, it's hard to read that shit, and it's hard to remember and edit it. And then there's one last point that I'll make, and then we'll move on. Sorry, I always try and keep these things condensed to like 10 or 15 minutes, and then I just end up rambling for nearly 30. The last thing is they're easier to test, and this is really important. And we're going to talk more about testing later, but most likely we will. But these systems are easier to test. So the last point I will talk about, and then I'll shut up about Model View Presenter. People wanted to know about Model View Presenters, so this is what I gave you today. But if I open up Pause Trainer, which is in the link in the description box below, and I navigate to the test source set, each of my presenters have a unit test class associated with them. So just really quickly, if I open, here I have alarm list presenter open. Each of these presenters is going to have a test class. And what each of these test classes do is for each decision that my presenter needs to make, and by decision I mean every time it reaches something like this, where it needs to potentially change what it does based on things outside of its control, it needs to decide what to do. For each of those particular decisions, I will write a unit test. And what that ends up looking like is I have a whole bunch of tests that do things like, for example, on get alarm list success. So when it actually gets a list of alarms, what should it do? And then I verify that behavior. And then, oops, I hate it when I randomly type things. And then when the alarm list is empty, what should I do there? I guess show a prompt. What should I do if there's an exception? And I test that. So I think hopefully you get what I'm trying to get at here. When you pull most of the logic, which is the stuff you need to test most, when you pull most of that into one single class, you can focus your tests on that particular area. Now, that doesn't mean you shouldn't test the model or the view. It's just, I find in my personal experience, you want to, if you're going to test anything at all, I would suggest testing the presenters or the logic layer. So that's my rambling, my little mini lecture on Model View Presenter, how it works, how to implement it. The last thing I swear I forgot to mention this is, in general, when you're talking to the data or the model, you're going to want to do that asynchronously. This is the last point I'll make, asynchronously. So you're either going to want to use RxJava. So for example, in this case, I'm using RxJava here. Also, the Blueprints project, it uses RxJava. Although I think this one might use RxJava 1. And the reason why I kind of didn't talk about it is because it can get very complicated very fast. Whoa. But yeah, anyways, you're going to want to use some kind of framework to talk to the model layer asynchronously, which is the last point I wanted to make, because you can't really expect the model layer to always respond instantly, and you need to account for that. Anyways, that's Model View Presenter. Hopefully that was interesting. I'm going to run a quick commercial break, and that's that. All right. Oh, I've got a very, very interesting and loaded question. All right, so who was it? It was Martin. Martin asks, this is a really great question. I'm just going to copy and paste it right over. So this question is from Martin. I can't remember if am I in full face cam mode? Yes, I am. Okay, so Martin asks, does the release of Google architecture components, Viewmodel, Live Day, and Room, mean Model View View Model is preferred over Model View Presenter, with the UI being reactive to view model changes. So this is kind of a good something I can kind of lead into, since I was talking about three-layer architectures in general. So the first thing I would like to say, and this is something you'll hear a lot on, for example, Fragmented Podcast, and I really like this statement. So there is no silver bullet architecture. There is no architecture that is going to work 100% optimally for every kind of application you build. So for one quick example is, let's say you're building an app with a really, really simple UI. Could you use data binding for that? Absolutely. Is it possibly overkill? Maybe. So what I would, here's my, before I get into answering this, two things. Number one, I'm going to be sharing my opinions, and if anyone disagrees with me, I'd love to hear the reasoning behind it. I did a lot of research into Model View View Model when I created my own tutorial. If you haven't seen that yet, I did like an hour and 45-minute tutorial where I build an application which uses Model View View Model and Android architecture components and Room database, and go check that tutorial out if you're curious about Model View View Model. Really quickly, let me show you a diagram of Mvvm, and then I won't talk about the pattern in detail or the architecture style. But here's kind of how I would interpret Model View View Model. So the way I built it is, we've got an activity, which is just a container. The fragment is a view, and the key difference between this thing is that how Model View View Model differs is that in Model View Presenter, this arrow you see here would point up to the fragment. It would just, these two things would reference each other. Whereas how Model View View Model works, really in a nutshell, is the fragment talks to the view model. It can send messages there, but the view model just updates this live data object, and the fragment just observes the live data. So there's no reference from the view model to the view directly. And that is all that Model View View Model is. That's how it's different. It just a single dependency in essence. Anyways, so I just wanted to really quickly, if people are curious about Model View View Model. Now the question was, does Google kind of recommending it as their architecture, does it mean it's preferred? What is that kind of, the difficulty here is that we've got Google appearing to, or the Android team, I should say, throwing their weight behind a particular type of architecture. And does that mean that it's the best? And that's the kind of question that, especially as a beginner, it's confusing as hell. Because it would be fairly safe to assume that Google makes good decisions like that, or the Android team. Here is my answer to that question. In essence, no, it doesn't mean it's preferred. What it means is the Android team is showing you a way to build applications which is very flexible, which does have good separation of concerns, I would say. And they've built components, for example, Viewmodel, which I was listening to a podcast. They weren't even sure if they were going to call it that. They've essentially built a set of components and an architecture which they kind of think is easy to manage and work with. And I would agree with that. The thing is, you can still build amazing applications with Model View Presenter. You can use parts of Android architecture components to improve your Model View Presenter architecture. Like, you could use live data. I'm sure you could fit a view model in somewhere. The thing about it is that here's the big issue with Model View View Model, and you'll hear me complain about this in the tutorial. The thing about it is that And just let me tell you a really quick funny story. So when I was researching this, my thoughts on model view view model were as so. There are as many ways to do model view view model as there are developers doing model view view model. There are as many implementations as there are developers. Every project I looked at, people did it differently. Some people actually had an architecture which was more like this, which was model view model controller. Some people had a controller in there. Some people didn't at all. Some people, holy crap, I keep getting messages from YouTube. The point I'm trying to get at is that when you think about these different architectures and when you see Google kind of throwing their weight behind something, it's difficult for me to put into words, but I would essentially say that the more I learn about software architecture, the more I see it's not a scenario where you pick one architecture and it's just better than the other. It's not even a scenario where one architecture is always done the same way. It's a scenario where if you have a given tool set, which in this case Google or Android just released one that works quite well with a specific style of architecture, you're probably going to make fairly good apps with it. I'm not sure if that really answers the question very well. I don't think it's here's how I would phrase it. I do believe Android is finally saying, hey, if you're going to use an architecture and you don't know what to do, here's this thing we're giving you. Here's kind of how to do model view view model. And they admittedly said that there's different ways to do it. Someone linked me to a podcast where Yeet Boyar and I forget it, Chet Haas were talking on some podcasts, and they basically said that they had the same experience as I did, which is that there's so many different ways to do model view view model. But yeah, I'm rambling all over the place. But if you don't have an architecture, absolutely this is preferred. Google is basically saying, if here is a method, here is one way you can build applications. We like this way. Fly at it, but you don't have to do it that way. You can pick model view presenter. You can really do what you want there. I feel like I went in circles with that question, but hopefully that kind of gives some insight. At the end of the day, go with what you're interested in. The only thing I really wouldn't suggest for Android is model view controller. I don't think model view controller lends itself to Android super well, but that's just my personal experience. Go with model view view model if you want to follow their way, and I have a whole tutorial where I build an entire app like that. Link is in the description box. It's the Room demo 2017, I think, Room persistence library. But also, after building a whole application and doing it their way, I still like my way with model view presenter and clean architecture better. So yeah, but I will still use architecture components in my model view presenter architecture. How's that for an ambiguous answer? Let's look for another question. Okay. Hello, A. Hopefully I'm pronouncing your name correctly now. A. Okay. What else have we got here? This is like the model view presenter episode. Yeah, Tina's mentioning my Recyclerview 2017 and how I divided it into view logic data, and this is just a random tangent, but in my Recyclerview 2017 article, I kind of show you how to build a basic 3-layer architecture, and I called it basically view logic data. just to get away from all the model view MVVM, VMC, RQ, STUV crap. Because at the end of the day, whether it's model view presenter or model view view model or model view controller, you've got 3 layers that basically do drawing stuff on the screen, logic and communication in the middle, and then data storage and access. And I think it's actually detrimental to really think about it more than that, to really be like, oh, how is model view, how are these different? Which one is better? At the end of the day, they all do really similar things. Anyways, random tangent. Oh, wow. So, Rahul, unfortunately, you probably missed my 30-minute. You'll be able to watch it earlier, but I did like a 30-minute explanation of Model View Presenter because I did feel bad when I read your comment. So do watch that when the recorded version is up. Okay, so let's do. I think I'm only gonna do 2 more questions because I'm bloody exhausted, but let's get a couple good ones in. So. I kind of already answered this in a previous. I've got a question about naming conventions, variables, interfaces, and their implementation. I'll do this. I'll give kind of a quick answer here. So the question by Linksy is what are my, oh my god, come on, naming. See, I normally type with the keyboard on my lap, so I'm screwing myself up. What are my naming conventions for member variables, interfaces, and what was the other thing? Implementation? And their implementation. So, as most of my regular viewers will know, I'm a major stickler, and the colloquial phrase I would use is I'm really anal about naming conventions. For my ESL viewers, they're probably thinking, what the hell does that mean? But it's just an expression. Being anal about something means being really stressed out and uptight. Anyways. So here's the main thing. I'm not going to spend a lot of time on this because I actually talked about naming conventions at length, I believe, last episode. But just really quickly, for member variables, I don't do Hungarian notation. I don't do that mview, mscheduler provider, mcomposite. I don't like it. It bugs the crap out of me. And there's this article written by Jake Wharton once, which the article is just say, I love it, no to Hungarian. Hungarian, I think that's how you spell that, notation. Hopefully that's how you spell Hungarian. That looks weird for some reason, but that's an article by Jake Wharton. Just dropping a name there, Jake Wharton. But anyways, I totally agree with that, and I before I even had reasons to, before I intellectually could explain why I don't like Hungarian notation, I didn't. There we go. Even before that, I wouldn't use it. I hated it. I was just like, why? No, I'm just not. Why are these things prefixed by M? Anyways, I forget the actual reasons why they do that. I think it has to be private member variables are written as mview and all this crap. Here's what I always do. So I go with the simplest and most legible thing possible. I basically rely on my IDE to sort of highlight the fact that some things are member variables and some things aren't. So I rely quite heavily on the IDE for that, and I don't use a special naming convention for member variables. And what do you call those? Not instance variables. I forget the stupid jargon names, but like the variable that comes in from a method, I totally forgot what you call that. But anyways, I don't particularly care. Maybe instance variable, although that seems like during one instance of a class. I don't fucking care. Anyways, so for variables, I call them the most basic name that I could think of. I'm not sure what happened there. Just basic and simple names for interfaces. So I've been kind of toying around with what to do here, but in general, I will call the interface of some kind of service. I'll call it just as like a, where is it? I'll prefix it with the model name. So in this case, the model is an alarm, and then I just have alarm source as the interface. So that's essentially what gets passed into the presenter is sources, which is the interface. And then I'll call the, for example, alarm database. If I had a local and remote database, I might call it like local database. I really get as specific as I feel I need to be. In the case of this thing, we've got alarm manager, which is an interface for this alarm service object. And alarm service just talks to a whole bunch of different services, which is why I called it that. In general, I'll give the interface a more general abstract name. I won't even specify whether it's a database, for example. You know, I kind of need to improve nail down my own naming conventions a little bit, but that's basically all I can share with you there. Like, there are people who, I've noticed my friend Darrell, he'll actually prefix, I believe, interfaces with I, so that look like I alarm source or something. You know, in general, just kind of find what works with you and stick with it. My goal is always to just write the simplest names possible that don't need a lot of confusing conventions to really understand, and that's why I tend to stay away from prefixing classes with special things. But if you're working with a big team and everyone's on the same page, that probably does work a lot better. Anyways, that was kind of a crappy answer, but hopefully that gives some idea. Okay. Yeah, pretty much. I like this. Tina was commenting. Tina was commenting that you either have to get used to saying in Hungarian notation no equals no, for example, or you're saying this dot no equals no. And I personally prefer, to me that's more legible, because it's like, once you understand that this is referring to the current object and you're just used to writing things that way, then you always, this to me is very unambiguous, but that, you know, it's a little bit down to personal preference, to be honest. To me, Hungarian notation just looks ugly. Anyways. I've got someone asking for a tutorial on Node.js and MongoDB. I'm an Android developer, bro. I might get there eventually, but... Okay, so I'm going to get to my last big question. I might do one more smaller one, and I'm not sure how well I'll do with this, but this was just a really interesting point of discussion, if nothing else. So this is again by Tina. And honestly, like, I'm really not the most qualified person to talk about this, but I can share my thoughts. And the question was, so for test-driven development, is it better to do state verification or behavior verification or a combination of both? And if I recall correctly, for example, Uncle Bob is really big on doing state verification. And if I'm not mistaken, he uses fakes primarily versus mocks. So all I'm really going to do here is just try and briefly explain what these things mean, and then I'll give a couple of thoughts on it. But I really don't feel like I have, I can give a definitive answer on it, is the thing about this. But Tina sent me an article earlier, and it was an interesting thing to read. And if you guys want to send me interesting stuff, hop on the Slack channel or message me on Facebook, and I do check it out from time to time. So, really quickly, what is the difference? Let's start with what's the difference between a mock and a fake. If nothing else, I'll teach you a little bit of practical stuff about tests. So the first thing is, now most people, there is a little bit of disagreement on what to call these things, and I understand why, because essentially you're using a whole bunch of words which in the English language all pretty much mean the same thing. But we've got a mock and a fake, and there's a bunch more terms, like there's a spy, there's a stub. I'm not even really going to talk about those because there's just too many words flying around for now. But in general, there's kind of two ways to test an application. You can use mocks or you can use fakes. So let's start. What is a mock? And I would just say a mock is on a, let's say, I like this, I think it was Jesse Wilson who used this term. I could be wrong, but a mock is we're going to just call all of these test doubles. So we've got like a test double, and then, so a mock is a kind of test double, which is the same thing as a fake. I'm just going to hold on a sec here. You see, I have to like change my explanations as I'm making them up on the fly here, so I apologize about that, but I can only think of explanations so quickly. So mock is a kind of test double, which is like the umbrella term, which I think it basically has to be made by, which is made by a mocking framework. So a mock should, how could I explain it? It's like a mock can be pre-programmed to deliver specific responses. It can be programmed to deliver specific responses, and it records interactions which occur to it during a test. I'll work through an example so that this word salad actually makes a bit of sense for beginners. And then a fake is a kind of test double, which is an actual class, and I'll have to just jump to code to really explain how these are different, but an actual class which delivers canned responses, So yeah, so let's just start with that. I know this might be a little confusing. Let's look at what an actual mock is. So if you're curious, go ahead and open up the POS Trainer repository down below in the description box and navigate to go to app, source, and test. And within there, you're going to see test classes for each unit test. Or sorry, for each presenter. Unit test classes for each presenter. And in this first example, I'm showing you how to use mocks to test the behavior of your application. And all this really works is I use Mockito, for example, which is a mocking framework. And as we can see, we have, if I open up the presenter itself, where the hell is it? If I open up the actual class, which I'm trying to test, again, this is weird because it's friggin', come on, brain. It's clean architecture, but we're talking to views and we're talking to use cases, which are essentially just like a way of talking to the model layer. Just pretend that this is all one giant model layer, but don't actually, because it's actually better to divide it into different things, but random shit. Essentially what we've got going on here is we have a presenter which needs to talk to these things. So it's either going to talk to a view or a model. That's really all that's going on here. And then in this case, I create, again, this is why the naming conventions are so annoying. I create mocks. So these are objects which they look the same to the presenter. So I can pass them into this presenter, a real instance of the presenter, but I'm giving it like made up framework generated versions of these classes. So a framework version of the view, a framework version of the alarm manager, for example. And so how that kind of works is that during the test, I basically, I tell the mocks what to do using Mockito. So for example, in this test, we say when the alarm source, which is an object I mocked up here, when alarm source, where was it, has get alarm, when the presenter calls get alarms on the alarm source, then return, and I just return some data that I made up here. And then and then when this actually executes, then I just check to see if presenter receives that data, and then it calls this particular method on the view. So in essence, what I'm doing here is, and hopefully this will make things a little more understandable, I'm testing the real presenter with mock view and model objects. And so for example, if I were to run this unit test and my presenter failed to call set alarmless data on this fake view, that would tell me that there is an issue. That would tell me that the behavior of my application is not correct. So that's kind of how you approach it from a mocking perspective, using a mocking framework and testing the behavior. Now, I'll be honest, I didn't actually make it very far with state verification. And I've never really had to with, I don't think, with ModelView Presenter. So, yeah, just let me catch my breath for a second here. So the question was kind of like, let me see if I can pull up an implementation where I've used fakes. Okay, so let me pull up a repo. I think I used fakes in Profiler. Let's see if I actually did that. Mock. Okay. So when I open up, so this is an older project, and this was, Profiler was the first project I ever tried, started doing unit tests with. It was the first time I ever did unit tests in a project, and man, I'm glad I started because it kind of introed me to TDD. Anyways, in this case, what I do is, let me pull up the test class itself as well. Now, I'm not actually going to suggest people follow the Profiler repository because it was like my first attempt at doing a lot of this stuff, but I just wanted to show you another way in which you can test your stuff. So let's look at, I guess, profile detail presenter test. Would that talk to the fake service? I think so. Yes. So in this case, again, we're using Mockito, and I still mock the view. So really, when I think about mocks, I'm generally thinking of objects which are simple and I don't really need to, I can expect them to behave in a pretty consistent way. And the way that I set up the, to use a fake, which this is what a fake is essentially. So in the case of a fake, you're creating an actual class, you're not using Mockito for it. And in this case, I would have my fake class implement the same interface as the actual class. So this is going to be implementing the same interface as the real database service, which is, if I recall correctly, a Firebase real-time database. And so again, all that we're really doing here is we're having our presenter talking to a model in a view which is kind of a test double. It doesn't actually exist. And unfortunately, I don't remember exactly if there were any benefits to approaching it like this. The one thing I found through using a fake in this case, the way I did it in here, is that I found my tests were... It was a little harder to test special cases where data wasn't really properly created. And I had to kind of add in these little public methods to my fake database test in order to actually simulate sort of error events and stuff like that. So you know what, that's all I can really say about using fakes. I do not have an adequate level of understanding to say, you know, is this a better approach than using mocks? But what I'll kind of end on here is that when it comes to testing presenters, I've never really seen a reason to warrant using fakes to sort of verify the behavior of my presenter. However, when we're getting into like testing the model itself and testing like back-end services, in that case, I could imagine that it, you know, it would probably end up being better just probably focusing more on the state of the application. So I don't really know, but I just thought I would talk a little bit about mocking and stuff like that. Let's do one more question. Anyways, I did read that article you sent me, Tina, but it's one of those things where it's going to take a little bit of studying. Unfortunately, I can't really, although I absolutely have nothing against dry code, I don't really watch tutorials from other YouTubers just because I want to avoid, it's basically a layer of security. Also, I publicly say quite often that I teach myself this shit, and I try to live by that, but yeah. Saroj is kind of mentioning that he had a problem converting my room demo project to Kotlin, so I will actually be rebuilding my room persistence library project in Kotlin. I'll look to do that in November or December. So I totally got you, man. I'll be rebuilding a couple projects in Kotlin very soon. I'm actually currently learning Kotlin. Tina kind of asks, is that what a fake is? That's from what I gathered, that is basically what a fake is it's creating an actual class with actual, it must contain implementation, whereas a mock doesn't contain any implementation. So to the best of my understanding, that is basically the difference between a fake and a mock, to use the technical terms, is a mock is an object which is created by a mocking framework, and that gives you certain benefits, like mocks know what methods were called on them and know how many times the methods were called on them, whereas with a fake, you're basically just creating like a fake implementation, essentially. And I'm trying to remember, I don't remember exactly why I switched to using mocks primarily, but I believe it was just because it's easier. It's faster to write tests using mocks, but for some reason I'm thinking that when you're designing these classes for the model layer, it's actually better to have a little more realistic of an implementation, but to be honest, I forget why. Anyways, yeah, that's basically it for today's episode. Awesome. We've got the input from Farts a lot. He wants me to fart on camera. I'm sorry, man, but you're I'm gonna have to disappoint you today. I eat a low carb diet, and my digestive system is on point today. Anyways, but thank you for contributing. Yeah, that's basically it. Thanks for watching. What I'll close out with is I did an update video, and I'll just kind of reiterate a little bit about it. So for the rest of October, I'm not going to make a lot of videos because I need to spend time learning Kotlin, and I need to spend time improving my own knowledge so that when I get these more technical questions, I can answer them better. So I'm not going to make a lot of content in October, but the reason for that is I need to improve my knowledge, and I've got big plans for November and December. One of the first things I'll do is I'm going to be rebuilding my calculator project in Kotlin, and I'll do a full app tutorial for that. And in that case, that will be a model view presenter Kotlin basic calculator application, and it's going to be sort of an intro to Kotlin. And then I plan to rebuild my room database and architecture components application, which will be model view Viewmodel in Kotlin as well. And that's basically what my plans are for then. But for now, I really need to do a lot more studying myself. So if you have questions, hop on the Slack channel. Also, one thing I appreciated, and this is something which Tina did, is before she asked a complicated question about state verification versus behavior verification in unit testing, she gave me a heads up on that, which was nice because obviously I didn't have a great answer because most of what I do is behavior verification. But it's nice when people ask questions ahead of time because then I have more. I'm not just like making an answer up instantly. And sometimes I can make up answers instantly and they're okay, but a lot of times I can't because this shit is complicated. I can't remember everything. And so if you have a complicated question, do me a favor, shoot me a message on Facebook ahead of time or join the Slack channel and get at me that way, because then I can oftentimes make like a whole dedicated lesson for it. So that's it. Thanks for watching. Peace out.